Hey guys, Alex here with Serious Goose Games, and welcome back to our Unity Tactics RPG tutorial. In the last video, we set up a little mock grid map or battle scene just to get an idea of what things are going to look like in the next few videos. Today we're going to set up code to instantiate the grid at runtime so we don't have to manually place all of our tiles. We're also going to assign names to the tiles and the little checkerboard pattern. So to get started, the first thing we're going to do is select all of our tiles and get rid of them. Because we're going to be instantiating it at runtime, we don't need those prefabs. Now we're going to go into our scripts folder in the project panel, right click, go to create, mono behavior script. This first script is going to be called tile. And this script is going to contain any logic we need for our tiles. Now we're going to do the same thing. So right click, create, mono behavior script. And this one's going to be called grid manager. The grid manager is going to control all of our big grid functions, so instantiating the grid. When we do pathfinding, it's going to include pathfinding. It's going to have helper functions for getting tiles and all of the little nitpicky things we might need our grid to be able to do. So once you have those scripts created, double click on tile to open that up. Once the script is open, we're going to get rid of start and update. And the only thing we're going to have in this script today is just a reference to the coordinates of the tile. So we're going to create a public vector2 int called grid position. Later on, we're going to have functionality on each tile. So if we hover over one or click on one, something will happen, and that's going to be in this script. But for today, just the position. Next, we're going to go to our grid manager script. And inside here, we're going to need some variables. So we're going to use the header field attribute, and we're going to name the header map settings. And Unity is nice because it lets us use these headers to organize our data in the inspector to make it easier to read and sort through and work with. And I'm trying to get better about using them. So if we get to a point and you see, oh, we probably could separate out the variables into different categories there, and I don't do that, call me out in the comments. So the data we need for our map, we need to know how big it is. So we're going to create a public int called width, and we're going to set that to be equal to 10 by default. And then we're going to do another one, public int height equals 10. Now, your map doesn't have to be square. I like square maps, so mine is square, but it will work regardless of, square or rectangle. And the last thing we need for this section is a reference to our tile prefab. So we're going to create a public game object tile prefab. Now, for changing the color of the tiles, we're going to need access to a couple materials. So we're going to create another header. And we're going to call this one materials. And inside here, we're going to have a public material called light material and a public material called dark material. And the last thing we need up here is a two-dimensional array to store all of our tiles. This is going to act as a data representation of our map. So we're going to create a private tile 2D array. We're going to call it map. Now, before we can use that map, we need to initialize it. So inside start, we're going to set map to be equal to a new tile two-dimensional array width, comma, height. So this will create a 2D array. Width and height will be its dimensions, which is good. It'll line up with our tiles, which is what we want. Now, the next thing we're going to do is get rid of update. We don't need it. And we're going to create a public void generate grid. Now, before we start, something I want to do that will hopefully be useful or helpful to you is periodically when we're writing code, I want to give you guys kind of homework, basically, where you can pause the video, try something out, and then come back. So before we start this, get a piece of paper or open up Paint or something and try to walk through the steps of how you would generate a grid using the information we have. When I've explained it in the past, I kind of make people think you have a box of little square Lego pieces. You need to put them into a grid. What are the steps you take to do that? So think about that. How would you arrange them as a grid? Write it down. Hop into the Discord if you have questions. You can ask questions about how you would do that. You can also share what you came up with, because there's a billion ways to program something, and you might come up with something that's better, more efficient, easier to read than whatever I have. So feel free to share. Anyways, this function, we're going to start out with a for loop. For int x equals 0, as long as x is less than with x plus plus. So we're going to loop through our x-axis first, and then for each unit on our x-axis, we're going to loop through our y-axis. So for int, sometimes the autocomplete is terrible, int y equals 0, as long as y is less than height, y plus plus. So for every unit on x, we're going to loop through our entire y-axis. So these two little for loops are going to give us a nice little ordered pair, and that's useful for setting the position of our tile. But if we set the position just based on x and y, our grid manager is going to be kind of in a corner, and that's not going to affect gameplay. It's not going to affect the code, really. It's not that big of a deal, and honestly, your life will be easier if you don't change that. But if you ever wanted to offset it for some reason, like I like to have my grid manager in the center of my map, or maybe you have some event that shifts a map over and then you spawn in a second map area and you want to offset or change or tweak something, knowing how to offset is going to be kind of handy. So what we're going to do inside here is we're going to create a vector 3, and we're going to call it tile position. We're going to set this to be equal to a new vector 3, and we're going to pass in x minus width divided by 2, 0, and y minus height divided by 2. So what this does is it offsets our coordinates by half of our map size, which will put our grid manager directly in the center of the map. And if it looks a little weird, because a vector 3 is x, y, and z, if it looks a little weird that our y coordinate is in our z spot, that's because most of the work we're going to be doing with our tiles uses this two-dimensional array, which is x, y. So this is one of the rare spots where we're actually going to use the z coordinate. So I'm not going to worry about it too much. With that done, we're going to create a game object reference called tile. So this is where we actually spawn in the tile. We're going to do this at each one of these ordered pair positions. So game object tile is equal to instantiate. We're going to instantiate a tile prefab. We're going to instantiate it at tile position. And for rotation, it's just going to be quaternion dot identity. Next, we're going to change the tile's name to make it easier to look at in the hierarchy. So tile.name is equal to $. We're going to interpolate a string, tile, and then x, comma, y. And the last little bit we need for instantiation is to set the parent. So we're going to grab our tile dot transform dot set parent. We're going to pass in the transform of our grid manager. So just transform. So this is going to make every tile a child of our grid manager. So if we ever move our grid manager or do something or modify it, it'll affect all the tiles as well. Next, we want to get a reference to our tile renderer so we can change the colors. So we're going to type renderer. We're just going to name it renderer. This is going to be equal to tile.getComponent renderer. Now for this next part, I'm going to give you the line of code we're going to use, and then I'm going to show you a different way to write it. So we're going to grab renderer.material is equal to a new material. And this creates a material instance so that if we modify this specific instance of the material, it's not going to affect everything that uses that material. But we need to pass in an original material for it to create an instance of. And to do that, we're going to use something called a ternary operator. So what we're going to do is add x and y. And we want to check if x plus y is even. And to do that, we're going to do mod 2 equals 0, question mark. So this is basically asking a question, is x plus y even or odd? If it's even, we want to use the light material. If it's odd, we're going to use our dark material. And that's going to create a nice little checkerboard pattern. The other way to write this is by writing if x plus y mod 2 is equal to 0, then renderer dot material is equal to a new material, light material, and then else renderer.material is equal to new material, dark material. So these two things do exactly the same logic, except this is one line of code. This is several. So ternary operators are really useful, especially if you're trying to modify a value based on a condition and you don't want to write out a huge if statement. So the last little thing we need to do is actually deal with our tile script. So we're going to grab a reference to that. Tile script is equal to tile.getComponent tile. Then we're going to grab our tile script dot grid position, and that's going to be equal to a new vector2 int x comma y. Now we're going to grab map at the position x, y, and this is going to be equal to tile script. There we go. That's the logic for instantiating our grid. Now, if you just wanted the tiles to exist in your world, you don't need any of this. Really, you don't need any of this. You can get away with just these two lines of code, and that will instantiate a grid. But we want our grid to actually do things later, and that's where the rest of this code comes in handy. Not including the material stuff. That's just for aesthetics. So go ahead back to start, and we need to call our generate grid method. Order matters in code. If I were to put this up here, it wouldn't work because in the function itself, we are utilizing the map. So if we try to utilize the map and we haven't initialized it yet, it's going to yell at us because that position we're trying to access doesn't exist. So we need to initialize the map first and then call generate grid. Once that's done, go ahead and hit save to save all your code. Head back to Unity. So now that we're back in Unity, grab your grid manager and drag your grid manager script from project into the inspector. If there's a blue line, you're doing it right. And once you attach it, you can see all of these exposed variables. We'll plug those in a moment, but next we need to go to our prefabs folder in our project panel, grab tile, and we need to attach our tile script. You can see once we do that, grid position appears as we want it to. Now select your grid manager in the hierarchy, and we're going to drag our prefabs and materials into their proper slots. So we're going to go to our prefabs folder, grab our tile prefab, drag that into the slot in the inspector. Now we're going to go to materials and drag these tile dark and tile light materials into their appropriate slots in the inspector. So dark goes here, light goes here. And that's all we need to do for setup. So if we hit Control S to save our scene and we hit play, it's not going to work. So if we hit play, you can see that our tile, we spawned in one tile, but that was it. Nothing else happened after that. And that's because it got stuck. And if we look into our console, missing component exception, there is no renderer attached to the tile 00 game object, but a script is trying to access it. That's because our tile prefab, we open it up. The tile object itself doesn't have a renderer. Its child, the tile art, does. And that's important because in the code, we're calling getComponent. But before we fix that, something I want to show you guys. In the console, it gives you the error, explains what the error is. And if you keep looking, it also tells you what line it's on, which is super useful for debugging. So in this case, it starts with where the error was thrown. In this case, it was thrown at generate grid line 36 because that function was called in start on line 20. So it kind of gives you a little path to follow back. So if we go to the code and we go to line 36, we can see right here, this is the line that's causing us problems, but this is where debugging is kind of a useful skill to have because it's not actually talking about this line. This is the line that threw the error, but the problem is actually on the line above it. We're getting component on our tile, but we need to do get component in children. So now line 34 should say renderer. Renderer is equal to tile.getComponent in children renderer. So if we save that and head back to Unity and we hit play now, if you followed all the steps and nothing went wrong, you should have a grid in the center of your screen. Or if you didn't do the offset step, it would be kind of off to the side. But you should have a grid. Everything should be there. It should have a lovely checkerboard pattern. And if we were to look at the hierarchy, we can see all the tiles are named after their coordinates. So tile 00 is at position 00. And when we select a tile in our hierarchy or in the scene view, and we look at its tile script, its grid position should reflect its coordinates. Now our grid doesn't do much right now other than look absolutely stunning. So in the next video, we're going to actually add interactivity to our grid. We're going to make it so that the tiles will highlight when we hover over them or turn a different color if we click on one. And that's going to kind of be the basis for our movement system. That's all for today though, so if you found this video helpful, hit like so more devs can discover the series, and subscribe so you don't miss the next episode. In the comments let me know, what size grid do you imagine your tactics game using? Are you thinking of smaller maps like Fire Emblem, or larger multi-dimensional maps like XCOM? I like how large XCOM maps feel, even though thematically they're pretty small. I think the verticality helps a lot with that. As always, thanks for watching. I'm Alex with Serious Goose Games, and I'll see you in the next one.